This is the car crash investigation by MJ, Khadija, Skyler, and Sarah. A traffic accident occurred in a 35 km/h speed limit zone where a 3,000-kilogram SUV rear-ended an Outback wagon that was stopped at a red light. The goal is to determine what happened and what traffic laws were broken.
The first thing to do was determine how fast the SUV and wagon were moving immediately after the collision. For the SUV, we are looking for the initial velocity since it's initially moving after the collision. The v squared equals v naught squared plus 2a delta x formula can be used to find the initial velocity. V squared is 0 since it comes to a stop. The acceleration was given, which was negative meters per second squared, and the distance was given as well, which was 2 meters. Plug everything in, and the final answer was 2.83 meters per second squared. For the wagon, the same formula is used, but the final velocity is being found instead. V naught squared is 0 since it was initially at rest. Acceleration distance is once again given. Plug everything needed, and the answer is 12 meters per second.
To find the velocity of the SUV before the collision, I found the total momentum before and after, which was done by applying the formula mv and then setting them equal and solving for the missing SUV velocity before the crash. And as you can see right here, I just did the SUV plus the wagon, and again I set them equal to each other, and I plugged in all of our givens, and the question mark is the one obviously that was missing, and I want to determine and find out. And so I found the total momentum for before and after, and then right here you can see is where I set them equal to each other and solved for velocity, which is 10.83 meters per second. To determine which type of collision it was, whether it was elastic or inelastic, I found the kinetic energy for both the SUV and wagon before and after, and I then added them up to a total, which is in the greens right here, and you can see the total before is larger than the total after, and so it was inelastic because there was a decrease in kinetic energy or mechanical energy being lost after the collision.
In order to draw the energy bar diagrams, we needed to identify the total potential and kinetic energies both before and after the collisions while considering the work due to non-conservative forces. So in each of the three following diagrams, there is no potential energy before or after because there is no gain or loss in height, meaning they're on the same level field the whole time. For the SUV, it had a greater kinetic energy prior to the collision, as you can see, meaning it lost kinetic energy. So the WNC was negative, meaning the difference between the before and after was subtracted from the before. The wagon had zero kinetic energy because it was at rest and gained kinetic after because it gained velocity. Therefore, the WNC was positive and the kinetic energy increased. As for the system, there was more kinetic energy present before than after the collision because the combined kinetic energies of both vehicles decreased. Therefore, the WNC was negative and kinetic energy was lost.
The force time graph for the SUV is displayed below the x-axis because kinetic energy was greater before the collision. This means kinetic energy was decreasing throughout the collision. The force time graph for the wagon is displayed above the x-axis because it gained kinetic energy after the collision, which means energy increased throughout the collision. Force time graph for the system, well, the wagon and SUV is displayed on the x-axis because both graphs before cancel out each other.
So based on all of our previous calculations, we were able to determine that the SUV was definitely at fault. The wagon was at a red light and the SUV failed to slow down to a stop and do the same as the wagon. Instead, the SUV was actually speeding at approximately 39 km/h, which is 10.83 meters per second converted, and it was definitely way over the 35 km/h speed limit on that Tequila Road zone.
This has been the car crash investigation. Thank you.